Hello everyone, welcome back to Control System lectures from Hiatuz. These lectures have been made on the basis of this book, and if you can follow these lectures along with the book, it will be most helpful to you. So I will leave the link for the book in the description box. In the previous lecture we discussed how to construct a polar plot, right? Now depending on the type, what is the type? It is the order of poles at origin. Okay, so depending on the type and the number of poles and zeros, we can get an idea of how the polar plot might be. Okay, so we will see how to understand this. Okay, now the first one is how will the type affect the polar plot of a system. Okay, so this will affect the beginning of the polar plot. That means at zero frequency. Say the transfer function is given by s plus z1, s plus z2 and so on, divided by s power k into s plus p1, s plus p2 into so on. Okay, so what is k here? K is the type, it is the order of poles at origin. Okay, now what will be the frequency response? Frequency response is when s is equal to j omega. So this will be equal to j omega plus z1, j omega plus z2 into so on, divided by j omega power k into j omega plus p1 into j omega plus p2 into so on. From here you can get the phase of the function like this: tan inverse omega by z1 plus tan inverse omega by z2 plus so on. Okay, so this is all the phase of the numerator minus phase of the denominator. Okay, so this will be k times pi by 2, because the phase of j omega is pi by 2 and the phase of j omega to the power k will be k times pi by 2. Okay, plus tan inverse omega by p1 plus tan inverse omega by p2 plus so on. Okay, now if you observe, at omega is equal to 0, that is at 0 frequency, what will happen to the phase? All these terms will become 0. Okay, what is the only term that is remaining at omega is equal to 0? This is only for 0 frequency. Okay, don't get confused. So at omega is equal to 0, the phase will just be minus k into pi by 2. Okay, this means that the phase of the beginning of the polar plot will simply be minus k into pi by 2. So let us say the system is of type 0. Okay, then what is the phase? The phase of g of j omega is equal to 0 degrees. Okay, and for type 1 this will be minus 90 degrees. For type 2 minus 180 degrees. For type 3 it will be minus 270 degrees, and for type 4 it will be minus 360 degrees, or you can simply go back to 0 degrees. So now again, if it is type 5, it will be minus 90 degrees. Okay, so this will continue like this. Okay, so the phase will be 0 degrees. It will be 0 degrees for type 0, 4, 8 and so on. Okay, and it will be minus 90 degrees for type 1, 5, 9 and so on. Okay, and it will be minus 180 degrees for 2, 6 and 10. Similarly, minus 270 degrees will be for type 3, 7, 11 and so on. So if you take the plane, this is the real part and this is the imaginary part. Okay, so for type 0, 4 and 8, the plot will start from this direction. Okay, this is 0 degrees. And for type 1, 5 and 9, it will start from minus 90 degrees, so this will be here. Okay, so this will be type 0, this will be type 1. Okay, and for type 2, 6, 10 and so on, it will be minus 180 degrees. That means it will be here on the negative real axis. So this is type 2. Okay, and type 3 will be at minus 270 degrees, or you can say plus 90 degrees. Okay, so for such type, the plot will start from the positive imaginary axis. Okay, now one important thing that you should remember here is this expression for phase that we have discussed here, this is valid only when the poles and zeros are lying in the left half of the S plane. Okay, that means that Z1, Z2 and so on, P1, P2 and so on, they all should be greater than 0. Okay, minus Z1 is the 0. Okay, and if minus Z1 should lie in the left half of S plane, then Z1 will be positive. Okay, so for this condition only, this expression for phase is valid. Okay, otherwise what will it be? It will be pi minus tan inverse omega by Z1. Okay, if Z1 is negative, okay, if the real part is negative, then the phase is found like this. Okay, so this expression that we have understood, that we have derived, it is only for poles and zeros lying in the left half of S plane. Okay, so that you should remember before using this shortcut. So we saw that the type will affect the beginning of the polar plot, that is the polar plot at 0 frequency. Okay, now the number of poles and zeros, this will affect the ending of the polar plot. Okay, that means at omega is equal to infinity. Okay, so here we will consider the magnitude. So we saw that what did we take the transfer function? G of j omega is equal to j omega plus z1, j omega plus z2 into so on, divided by j omega to the power k into j omega plus p1, j omega plus p2 into so on. Okay, so here if you take the magnitude mod g of j omega, you will get root over z1 square plus omega square, z2 square plus omega square into so on, divided by omega to the power 2k, okay, into omega square plus p1 square into omega square plus p2 square into so on. Okay, so this is all under the root. Okay, now what will happen? Let n, we will take the difference between the number of poles and the number of zeros. Now what will happen when omega tends to infinity? Okay, the magnitude mod g of j omega, this will be equal to 0 for n greater than 0. That means if number of poles is greater than number of zeros, then the magnitude will be 0. This you can take an example and you can verify by applying the limits. Okay, and for n is equal to 0, that means the number of poles is equal to number of zeros, then you will get a finite value, some finite value. Okay, but it will not be 0, finite value but not 0. Okay, and for n less than 0, that means the number of poles is less than number of zeros, then the magnitude will become infinite. Okay, so these are the three cases. This is the magnitude. What about the phase? It will be just like in the previous case we have already discussed. Angle g of j omega is equal to tan inverse omega by z1 plus tan inverse omega by z2 plus so on, okay, minus k times pi by 2 plus tan inverse omega by p1 plus tan inverse omega by p2 plus so on. Okay, now what will happen when omega tends to infinity? Okay, when omega tends to infinity, each of these terms will become tan inverse infinity. What is tan inverse infinity? It is pi by 2, 90 degrees. So now what will be the phase? If you consider the number of poles to be, let us say P, okay, and the number of zeros to be Z, then the phase will simply be equal to the number of zeros Z into pi by 2, okay, because each of the zero term will contribute to pi by 2 degrees, okay, minus P into pi by 2, okay, each of the pole will contribute to pi by 2 phase, okay. So this will be equal to Z minus P into pi by 2. What is number of zeros minus number of poles? It is minus n, okay, minus capital N. So this will be equal to minus n pi by 2. So for the case of n greater than 0, that means the number of poles is greater than number of zeros, the plot is approaching 0, okay, and what is the angle of the plot? It is minus n pi by 2. That means it is approaching the origin at an angle of minus n pi by 2, okay. Now the other two cases, n is equal to 0 and n is less than 0. So here the plot will not approach origin at omega is equal to infinity, okay. So we will not be discussing that case. That case you will have to solve classically only, okay. So there is no shortcut for it. So for n greater than 0, if you take the real and imaginary parts, okay, then when n is equal to 1, what will be the phase? It will be minus pi by 2. That means the polar plot will be reaching the origin at an angle minus pi by 2, okay. This is the case for n is equal to 1. What will happen when n is equal to 2? The phase will be minus pi. That means the plot will reach the origin at an angle minus pi, okay. And similarly for n is equal to 3, the phase will be minus 3 pi by 2. So the plot will be reaching like this, okay. And again if n is equal to 4, then the angle will be minus 2 pi, that is nothing but 0 degrees, okay. So the plot will be reaching like this. This is the case of n is equal to 0, okay. Again n is equal to 5, it will continue like that, okay. So this is how the ending of the polar plot will be affected by the number of poles and number of zeros.